The Committee on the Environment will come to order. Good morning, everyone. Welcome to today's hearing entitled Restoring U.S. Leadership in Weather Forecasting, Part 2. In front of you are packets containing the written testimony, biographies, and truth and testimony disclosures from today's witness panels. And I now recognize myself for 5 minutes for an opening statement. I'd like to thank the excellent witnesses for being with us today. We have two panels, and first, Dr. Sullivan, thank you especially for being with us. We had the chance to spend some time together last week, and I enjoyed that and appreciated the opportunity to get to know you, and we look forward to working with you on many important issues. I'd also like to welcome the subcommittee's new vice chairman, the gentleman from Mr. Oklahoma, Mr. Bridenstine. This hearing is the second installment in a process that we began last month to discuss legislation to enhance weather forecasting throughout targeted research investments in the National Oceanic and Atmospheric Administration. Severe weather routinely affects large portions of the United States, and this year is no different. As we've discussed in part one of this hearing, the United States needs a world-class weather predicting system that effectively safeguards American lives and property. Today we are discussing legislation that was recently introduced by Vice Chairman Bridenstine, a bill that I'm proud to co-sponsor. The Weather Forecasting Improvement Act of 2013 prioritizes forward-looking weather research, improves procurement of observing systems, data from space and land, and opens up NOAA processes to encourage private sector weather solutions. The legislation is a down payment to upgrade our weather predicting systems that has fallen behind according to international standards. And let me be clear that what the goal of this bill is. It makes the protection of lives and property through improved forecasting the top priority for NOAA. The bill does not micromanage the agency, and I know, Dr. Sullivan, you will appreciate to hear that, but instead expands resources available for achieving this objective. I appreciate the wise counsel of the witnesses testifying today, and I think we can all agree that improved weather prediction is a goal worth pursuing. We should not let the perfect become the enemy of the good, and in these tight fiscal times, it is absolutely vital that our first and most important research programs are authorized by Congress and thus more protected from future budgetary constraints. At this time, I'd like to yield the remainder of my time to the Vice Chairman from Oklahoma, Mr. Bridenstine, to discuss his legislation and the positive impacts it would have to protect his state and this nation from the life-threatening severe weather.
Thank you, Mr. Chairman, and thank you for your leadership and for your co-sponsorship, and I look forward to working with you on this. I wanted to take just a few moments to recognize some important points about today's hearing for me and the people of my state. Let me begin by saying how truly honored and proud I am to be here. This is my first hearing as the Vice Chairman of the Subcommittee on the Environment, and recent events have made me even more appreciative of the opportunities we as a committee will have to do important work for the American people over the next 18 months. As every Oklahoman knows, tornadoes are an unavoidable challenge faced by millions of Americans. But we know equally well that every minute we can add to our tornado detection and alert system has a direct effect on the number of lives that can be saved. As the subcommittee with jurisdiction over the agency responsible for weather research and prediction, the National Oceanic and Atmospheric Administration, or NOAA, I believe we have a moral obligation to advance legislation to the full House that forces NOAA to place its highest priority on what is undoubtedly its most important duty, enhancing public safety through timely and accurate forecasts of severe weather systems. To implement these much-needed reforms, I have recently introduced the Weather Forecasting Improvement Act of 2013. This legislation would establish within NOAA a tornado warning extension program aimed at improving the average time for a tornado warning from a few minutes to an hour or more. NOAA itself has indicated that this is a worthy and achievable goal, but sufficient resources and a dedicated effort is needed to make it a reality. This legislation aims to accomplish this not by requesting or spending any new funds at NOAA, but rather by shifting their priorities and resources away from lower priority climate and ocean research and towards weather forecasting, research, and innovation. The inadequacy of attention to potentially life-saving advances in weather forecasting is evidenced by the fact that NOAA's research arm currently spends more than 3 times as much on climate change research as it does on weather forecasting research. Across all government agencies, the differences in these misplaced priorities can be measured in the billions of dollars. Today's hearing is an important step towards the legislative solution needed to fix this problem. Finally, I want to thank Acting Administrator Sullivan and all of our witnesses for appearing here today, and extend a particularly warm welcome to Dr. Kelvin Drogemeyer, who will be joining the second panel from my home state of Oklahoma. Dr. Drogemeyer has been an invaluable resource both for my office and the staff of the Science Committee as we have developed this legislation, and I thank him for making the trip from the University of Oklahoma today to lend his perspective and answer questions for our committee. Thank you, Mr. Chairman, and I yield back.
Thank you, Mr. Bridenstine. I now recognize the ranking member, the gentlewoman from Oregon, Ms. Bonamici, for her opening statement.
Thank you, Chairman Stewart, for holding this hearing today. This is our second hearing to consider legislation to improve the National Oceanic and Atmospheric Administration, NOAA's, weather forecasting abilities. And I appreciate your willingness, Mr. Chairman, to work together to plan this hearing, and I'm very pleased that we ended up with such a distinguished panel of witnesses. The views of NOAA, as represented by Dr. Sullivan, as well as those of the other three witnesses from the non-governmental portion of the weather enterprise, will greatly enrich our understanding of how to improve weather forecasting. And I want to thank you, Chairman Stewart, for the bipartisan spirit you've shown in inviting collaboration on legislation. The draft bill we took testimony on in the first hearing has been replaced and expanded upon in the bill introduced by Subcommittee Vice Chair Mr. Bridenstine. There are many elements of that bill that are promising, and I'm particularly enthusiastic about the new section on tornado forecast research. I want to applaud the gentleman from Oklahoma for including that provision. We all agree that weather forecasting can and must be improved. As we learn more about weather forecasting in the United States, how it is done, and the partnership that's evolved among NOAA, academic researchers, and private businesses, it becomes evident that the core of the bill should be refocused away from its emphasis on research at OAR, or the Office of Oceans and Atmospheric Research, and more on the actual forecasters' needs at the National Weather Service. Putting all of our legislative emphasis on the OAR seems inconsistent with our stated intention of improving forecasting and protecting lives. OAR is a research arm in NOAA that manages oceans, Great Lakes, climate, weather, and computer research. It makes more sense, Mr. Chairman, to authorize the National Weather Service directly and put the forecasting operation in the lead on guiding research into innovations that have real utility. If our goal is to enhance forecasting, empowering the forecasters would seem to be the obvious way to proceed, and this is, in fact, the way the Army, Navy, and Air Force all do their research to operations efforts. Additionally, the bill as drafted may create unnecessary conflict between the researchers at OAR and the forecasters and researchers at the National Weather Service, as well as between the weather portion of OAR and the oceans and climate portfolios at OAR. We need progress in all of these areas to improve forecasting. As Dr. Sullivan concisely explains in her testimony, in the scientific world, weather is classified at shorter timescales, which technically extends to 2 weeks. Any forecast timescales beyond 2 weeks are classified as climate. So emphasizing weather research over climate research is likely to be counterproductive. As Dr. Drogemeyer states in his testimony, all of us recognize the importance of balance between weather and climate investments in our nation's research and operations portfolio. Yet the traditional line dividing weather and climate is increasingly blurred, as climate models are now run at resolutions approaching those of weather models. Consequently, we would do well to consider weather and climate not as two distinct elements at the extreme ends of a spectrum, but rather as inseparable parts of the Earth system. And I look forward to Mr. Drogemeyer's testimony further on that. Mr. Chairman, I'm confident that working together, we can craft a bill that is on target with the needs of the weather community, fiscally responsible, and protective of public safety. I'm very optimistic that this subcommittee can draft a bill that is constructive and truly bipartisan. If we closely study the testimony we have received, it will give us a good guide for how to move forward, and I hope we can do that together. And with that, Mr. Chairman, I yield back.
Thank you, Ms. Bonamici, and let me state as well that we look forward to working with you and other members in a bipartisan fashion, as I think is appropriate for a subcommittee such as this. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. It's now my honor to introduce our first witness panel, and our first witness today is the Honorable Catherine Sullivan. Acting Undersecretary of Commerce for Oceans and Atmosphere, and Acting Administrator for the National Oceanic and Atmospheric Administration. Previously, Dr. Sullivan served as Assistant Secretary of Commerce for Environmental Observation and Prediction, as well as performing the duties of NOAA's Chief Scientist. She is a distinguished scientist, a renowned astronaut, which is, in my opinion, very cool, and intrepid explorer. Dr. Sullivan earned her doctorate in geology. And as I'm sure, Doctor, you know, spoken testimony is limited to 5 minutes, after which the members of the committee will have 5 minutes each to ask you questions. So I now recognize Dr. Sullivan for 5 minutes to present her testimony.
Thank you, Chairman Stewart, Ranking Member Bonamici, members of the committee. It's a pleasure to be with you this morning. I would like to start by thanking you for your support for NOAA. We share a goal of improving United States weather forecasting, and so we welcome your interest in something about which we throughout the agency also care very strongly. While the intent of the legislation that is submitted is a very good one, we do have still a few serious concerns about some aspects of the bill. We look forward to working with you to discuss those in the weeks ahead. The products and services that the nation has come to rely on from NOAA require research across many science disciplines and scales. I look forward to working with you to refine some aspects of the bill that will ensure that we can reach our shared goal of improved weather services and products. NOAA is trusted with the responsibility of providing environmental intelligence to American citizens, businesses, and governments. This is what we all need to enable informed decisions on a range of earth science issues and scales, from the local to the global and the short term to the long term. We provide a suite of products and services, including reliable and timely delivery of public weather warnings that save lives and property and enhance our national economy. Much of our success in providing these products and services comes from scientific and technological breakthroughs produced by research across scientific disciplines and a range of time and space scales. Therefore, we caution and appreciate the committee's concerns about erecting artificial boundaries between these disciplines or across these scales that would hinder the advancement of our mission and the critical research that can help achieve the goal we share. Our understanding of Earth system phenomena along short and long time scales strengthens our weather products and services and allows us to examine the ways in which we can make improvements, such as highly accurate hurricane track predictions, further in advance. Emergency management officials have indicated to us that at ideal capacities, NOAA would provide highly consistent and accurate hurricane landfall predictions at days 5 and 6, allowing for pre-positioning of crews and enhanced evacuation efforts. Many economic sectors would see significant cost savings with highly accurate drought predictions, ranging 6 months to several years in advance. If NOAA is to achieve these goals and also achieve the improved warning we need on severe and acute events like tornadoes and severe storms, we must have the flexibility to research both shorter and longer timescale phenomena. Historically, weather and climate models only incorporated atmospheric inputs and outputs. In recent years, scientists have recognized the need for these to be integrated with ocean observation and science to provide a more accurate picture of how our entire Earth system works. For example, the El Niño Southern Oscillation, or ENSO, is a recurring pattern of periodic warming and cooling in ocean temperatures off the coast of South America. These significant changes in tropical Pacific water temperature affect weather patterns worldwide. Daily and seasonal weather in the United States are affected by these slightly longer-term seasonal climate events. So improving our weather forecasts requires that we follow the science and apply our research and observational efforts appropriately across this continuum of time and space. Advanced computing assets and modeling methods are also crucial elements of our national forecasting infrastructure. Over the past 2 decades, our tornado warning lead times have more than doubled, and we share your aim of continuing to improve the timeliness of such warnings. Computing capacity and computer modeling are indispensable to this. The upgrade to NOAA operational computers that is scheduled to be completed next month marks a big step forward, and we thank you for supporting the Disaster Relief Appropriations Act of 2013 that made this possible. In addition, the President's fiscal year 2014 budget requests further funds for NOAA to take the next vital step forward in operational supercomputing, ultimately providing a 27-fold increase in computing capability by 2015 and putting us on par with the world-leading forecast centers again. NOAA uses many tools to help determine what new data or technologies will yield the best improvements in forecast accuracy and so warrant investment. Observing system simulation experiments, or OSSIs, are just one of these tools. They are computationally intensive and time-consuming. Observing system experiments and adjoint simulations are two other tools that can provide similar analytical insight and rigor much more efficiently. Thus, we would hope the final bill would not stipulate that only OSSIs be used to assess the relative value and benefits of observing systems. NOAA regards the protection of the people of the United States from the devastation that weather can bring as a sacred trust and duty. Fulfilling this obligation requires a robust, flexible, and integrated program of sustained environmental observations, scientific research aimed at computing our forecasts and warnings, and cutting-edge modeling and computing. Our end goal is a weather-ready nation. We appreciate the bill's intent to advance this cause and look forward to working with you to refine its provisions. I thank you again for the opportunity to testify on this important matter, and I'm happy to take your questions.
Thank you, Dr. Sullivan, for your testimony today. Thank you for your extraordinary service to your country through many years. I would remind the members that committee rules limit questioning to 5 minutes, and the chair will, at this point, open the round of questioning, and the chair recognizes himself for 5 minutes. Dr. Sullivan, you mentioned a couple things in your testimony I'd like to maybe expand on a little bit, and the first one I'd like to go a little quickly, saving time for perhaps a second question as well. You mentioned the money provided by the Superstorm Sandy relief funding that was appropriated recently, and that NOAA has committed to Congress to immediately undertake two very important OSSEs, or the Observing System Simulation Experiments, to assess potential gap-filling satellite technologies. And in our meeting last week, we had a chance to talk about this just a little bit. GPS radio occultation and the geostationary hyperspectral sounding. For this latter technology, can you explain to the committee your evaluation criteria? Are you going to evaluate a constellation of 6 instruments around the globe, or only a single sounder here in North America? And can you then give us some insight in, with that decision, how that will affect the results of these experiments?
Thank you, Mr. Chairman. That observing system simulation experiment, as I understand, is still being formulated. I don't have at hand the detail of whether the initial plan is to do a single instrument or then a full complement of 6, or what the time and computational resource required to do either and both of those would be, but I'd be happy to get that for you.
Okay. Help me understand, can you get meaningful data with just one, or do you really need 6 to draw very meaningful conclusions?
That's a very subtle technical answer that goes to how the data would be incorporated into global forecast models. So I would have to get some of our scientific experts to give you a view on that.
Okay. Well, I look forward to those, that reply from you. It would be helpful for us. And, I wouldn't presume that you can't achieve what you want to do with only the one, but it would certainly seem like, 6 is much more meaningful. And I'm sure you have constraints regarding funding that would impact that.
Certainly to provide, when you run a global model, you need to initialize it, start it out with some initial conditions. And to do that, you need to sample the entire globe. So we take today, for example, polar satellite data, sounding data from all across the globe, and we take ground-based instrumentation data from all across the globe, shared by international partners at no cost to each nation. So that's the current initialization. It does make first-order sense if indeed the performance of the hyperspectral sounder proved out as is postulated in the written literature. It certainly might make sense that density and precision could aid in the initialization of global models.
Okay, thank you. And again, we look forward to more detailed response on that. I think you'll like my second question. It's a little easier, perhaps. We've seen so many advances in technology, such a greater result over the last couple decades, certainly from when I was younger, and it's remarkable, really. But, of course, there's much more that we can do. And so I would ask you, what are some of the promising technologies and some of the promising research areas that you're not able to pursue because of some perhaps restrictions in funding? What would you like to be doing that you're not able to do right now?
I would focus on 2 things, and my answer will pick up a piece of Mrs. Bonamici's statement. One of the things that we have found most fruitful within NOAA to making really advancing the research, making sure we've got a sharp focus on the most important things to move forward on, and ensuring it couples closely and rapidly into the forecast world, are co-locations and test beds. So I can cite two, one from the Vice Chairman's home state, which I know he knows well, at the National Weather Center at the University of Oklahoma in Norman. We have co-located the National Weather Service's Weather Forecast Office, the actual operational forecasters, our National Center for Severe Storms Prediction. Anytime you see the Severe Storms Center says on your television, that's coming from NOAA, from the main forecasting engine that produces American weather forecasts. And finally, our Office of Oceanic and Atmospheric Research's National Severe Storms Lab. Putting those three entities so close together, letting the scientists and the forecasting experts really work very flexibly and fluidly with each other, and work together around what has been developed there called a hazardous weather test bed, has really been made a tremendous difference in the rate of advance and refinement of the forecasters' tools. So what we aim to do at NOAA, frankly, in essentially all of our research, we're not really a blue sky research agency. Yes, we do research that's labeled climate. Far the great majority of that research within NOAA is seasonal to interannual and very directly oriented towards understanding the longer-term underlying patterns that shape daily and seasonal weather in the United States. And these close couplings with the Severe Storms Lab, the test bed, the Storm Prediction Center, and the forecasters have proven very fruitful. I'd love to replicate that model in more places.
Okay, great. You know, and my time has now ended. Maybe I'd close with just these two observations. The first is obvious, and that is, as Mr. Bridenstine has indicated, in what took place recently in his home state, there's more that we can do, and the technology is available for us now, perhaps where we can take some generational leaps forward in providing a longer warning period and more safety and security for people, and we look forward to working with you in helping that come to pass. The chair now recognizes Ms. Bonamici for her questions.
Thank you very much, Mr. Chairman. And I want to follow up on your previous answer, Dr. Sullivan. But before that, I want to join the chairman in thanking you for all your service. I really liked reading in your testimony about your view from the shuttle, showing the interconnectedness of all the systems. So following up on your last answer, Dr. Sullivan, according to some weather experts and people who have raised concerns about proposals to reallocate significant resources from NOAA's climate and ocean investments to weather forecasting. So I noted in several places in your written testimony where you caution us against actions to increase one important mission area to the detriment of NOAA research programs in climate or ocean science. So will you please explain how climate and ocean research and research flexibility are critical to NOAA's mission of providing more timely, accurate weather forecasts?
Thank you, Mrs. Bonamici. I'd be delighted to do that. Let me open by saying that weather forecasting and the forecast services that protect American lives and livelihood are already NOAA's highest priority. They are encoded in national security functions that we are directed to fulfill by the President of the United States in support of the Commerce Department's mandates. So they stand already far head and shoulders above many other things that we do. How is this flexibility important? How does it help us? Let me cite our Hurricane Forecast Improvement Program to give you an example of that. This was assembled after a spate of landfalling hurricanes, very devastating hurricanes. We brought together academic, federal, outside researchers and forecasters. We looked at the spectrum of underlying causal factors, what patterns in the atmosphere lend to the formation of hurricanes, shape them, steer them, stop them. What phases of things do we need to understand? The answer is a mixture of things, ranging from understanding decades-long oscillations in the Earth that put the Earth sometimes in a phase we're in now, where the Atlantic Basin is very active, and then a few decades later in a phase when the Atlantic Basin is not very active. That's a deep underlying heartbeat of the planet. To know the predictability of hurricanes, we need to understand those kind of longer-term heartbeats. But to really get track and intensity right, it's also clear on the other end of the scale. We need to have models that can resolve the actual inner core of a hurricane very precisely. So this Hurricane Forecast Improvement Project set out an array of research endeavors coupled to this purpose across that time scale. They cross-check regularly and frequently which ones are advancing. They created a stream that could advance and yield benefits to forecasting with the operational supercomputing assets in place at the moment. And they yielded a second stream that could take us even further if we could step ahead the capacity of the operational supercomputer, like way ahead. And then they created another stream to bridge them and make sure that we didn't leave good results sitting on the sidelines for any longer than are necessary. The flexibility of this sort of integrated team to move those pieces back and forth under a broad charge given by the Congress to get better at hurricane forecasting, hit these targets by these times, and then the throttle setting that the Congress can allow us each year in the appropriations has really made that a tremendously fruitful program. I think that's a great model to emulate.
Thank you. And this is similar to the chairman's second question. Based on your years of experience and your expertise, what changes, if any, should be made to the structure or processes at NOAA to provide continuing improvement in weather forecasting? Are there some structural things that could change that would help improvement?
We're trying to make some of those now, and I think a couple others could help. Again, I would cite the Hurricane Forecast Improvement Program. It had many strands of activity under it, but it was agreed upon with the Congress at the level of the program and then appropriated at that level each year. That, in my view, is a sound and healthy balance of the rightful prerogatives of the Congress and the flexibility needed to adjust programs as they evolve and deal with setbacks when they occur, as they will in the research arena. We have also, I think, if we can improve the way we all look at keeping NOAA's operational supercomputers closer to the cutting edge, we would find a great improvement there. And I'll give you one great example. We have research models running. In fact, the research model that runs under the hurricane program cannot be put into the operational supercomputer right now. So during hurricane season, we run the National Hurricane Center, and we run this research model in real time because we can't fit it into the operational supercomputer. We should be able to fit it in. We have a model that could have forecasted last year's derecho 12 hours in advance. It did. It did, but it was running in research mode. We need to be able to move those more rapidly into supercomputing rather than waiting so long for big step functions in our supercomputers.
That's very helpful. Thank you very much, Dr. Sullivan, and I see my time has expired. I yield back, Mr. Chairman.
Thank you, Ms. Bonamici. We now recognize the Vice Chair, Mr. Bridenstine, for 5 minutes.
Thank you, Mr. Chairman, and thank you, Dr. Sullivan, for being here. I just have a few questions. You would agree that increasing tornado warning lead times is, as much as 1 hour is a priority of NOAA's?
I wouldn't set 1 hour necessarily as a priority, Mr. Bridenstine. There's a significant response question as to what people would do with 1 hour. And I think we've begun mounting, in concert again with the Weather Center down in Norman, some social science and risk communication research lines to understand, A, is that the right target to set? And B, if it were, what do we need to understand about how to present and communicate that so that it doesn't become something somebody heard and then got busy in something else, and then by the time the hour came, they were immersed in a video game and the tornado ran right over them.
So more lead time would be more dangerous?
More lead time if it triggered the inappropriate response to take safety. Could be inimical to the game.
You're impugning the motives of the people we're trying to protect. If they had an hour lead time, that'd be better than 16 minutes, which is what the people in Oklahoma got this time, correct?
I do believe longer than 16 would be beneficial. I'm simply saying there's a genuine question about how humans respond to impending risks that our risk scientists tell us we need to be cautious about in just imagining that an hour or a day is the right time frame to communicate on. So I consider it an open question.
So the government should make decisions about how much lead time we give people because we know better than they know how to protect themselves.
No, we should understand how to communicate the information we have so that it's effective for the people who have those decisions to take.
So let's say we had an hour lead time. Would you suggest we should withhold that information because an hour is too much and people aren't smart enough to take cover?
We provide 5- and 3-day outlooks now to citizens and to emergency managers in a rich dialogue that has evolved over time to where we all know how to respond to that information. And again, there are powerful instances from your home state and town of communities doing just that. I'll defer to Dr. Domeier to amplify on it. He's lived through them. So I'm not saying withhold it. I'm simply saying that the challenge of communicating forecast information effectively to decision makers is a genuine question that needs to be approached thoughtfully. And the best scientists I know on this question caution me, including scientists at the National Weather Center, caution me that they're questions we need to probe together to be sure we would communicate that information effectively and not unintentionally have exactly the result we didn't want.
Okay. You're familiar with the phased array radar, obviously, that's in Norman, Oklahoma, and
I am.
I'm a Navy pilot myself, and certainly I've been involved in these kind of technologies from a warfighting perspective, and the ability to detect, targets from long distances and direct energy in a very specific and dynamic way to get precise measurements. I think is critically important. Is this technology something that you believe we could advance to the point where we could deploy it in a way where we could get an hour lead time?
It is. I don't have the technical acumen to conclude that phased array radar itself is pivotal to that. We're still learning a lot about what the dual polarization NEXRAD radars can give us. And I would go back to the example that I cited to Mrs. Bonamici in assimilating NEXRAD, current radar, into very fine resolution models, which we're running in research mode. Last year, in June of 2012, in fact, very accurately forecast the derecho line of very severe storms, which were tornadic strength storms, 12 hours in advance. So we do already know finer scaled modeling, which requires much better computing capacity operationally than we currently have, and proper incorporation of that data. All three ingredients are critical. It's not just bioradar. But those three, we have demonstrated, could give us 12-hour very good, not just the convective probability, but there's the storm line, and here's where we're propagating. MPAR certainly offers additional promise, but we've had one of them that we're still experimenting with to understand just what that potential could be. And as your bill suggests, be sure that we really understood its contribution before we might make any nationwide deployment decision.
Let me ask you, if you were in Moore, Oklahoma, and somebody said to you, maybe we shouldn't have this type of research because if we gave you too much information too early, you might not act on it. How do you think my constituents in Oklahoma would respond to that?
But that's not what I'm saying, sir. I'm saying that I want to be sure I say to you, go now, or some communication that you really register as the one that will prompt you to the action that you should take. And that the language, style, mode of that communication is something that needs to be studied and worked with people like your constituents.
Okay. I yield back.
All right. Thank you, Mr. Bridenstine. And now we turn to Ms. Edwards.
Thank you, Chairman Stewart, Ranking Member Bonamici. I appreciate today's hearing on weather forecasting. In my view, it's a necessary part two on a subject that greatly impacts the American public and our greater economy. And I'm pleased that NOAA, which is headquartered in my congressional district, thank you, Dr. Sullivan, has the opportunity to be before our committee today and to discuss efforts to improve weather and climate forecasting. Today's panels are an improvement, I think, on the last that we've had. I'm concerned about the legislation that we're discussing today, and as indicated in the testimony of our witnesses, the legislation is really flawed in its execution, in my view. NOAA is a multi-mission agency, and that means its priorities, ocean, atmosphere, climate, and weather, are interconnected. I think Dr. Sullivan has testified to that today. And given what we've learned and experienced with increasingly severe and more frequent severe storms, hurricanes, tornadoes, flooding, it's hard for me to believe that you can separate or slash funding of climate research when all of our weather scientists and our forecasters indicate the kind of interconnectivity that Dr. Sullivan has discussed. Our Earth is a system, and I think in order to understand the processes, we have to understand it as a whole. And so with that, Dr. Sullivan, I know we've had a couple of one-on-one conversations about NOAA's work and concern about where we stand vis-a-vis Europeans in weather forecasting. And I know we talked about the lagging in our supercomputer computing power as evidenced by some of the different modeling that we saw with Hurricane Sandy. And so I wonder if you could explain to the committee some of the institutional differences between the U.S. government's role in weather forecasting versus Europeans that keep NOAA from being as cutting edge as we'd like it to be.
Thank you, Mrs. Edwards. The model that received such acclaim rightfully during the evolution of Hurricane Sandy, especially the early days, is a model run by the European Center for Mid-Range Weather Forecasting. That is a combination research and operational forecasting center that is charged with one and only one thing, and that is to run a global model that gives a 10 to 12-day forecast. They've become very good at that. It is definitely one of the leading models at that time range. What else to say? That is all they do at the European Center. So the rest of the products and services that most national hydrometeorological services like NOAA are charged with fall to the UK's Meteorological Office or Meteo France or the Deutsche Wetterdienst. So to really understand what Europe is doing, you need to take a look at both the European Center and the collection of federal or national level weather services throughout each of the European states. That's closer to comparable. What else does European Center do that we would love to emulate more closely? They make consistent progressive investments in their main operational supercomputer. They have set a target and a policy of staying very close to the bleeding edge of computational capacity. In the United States, in contrast, we tend to step forward an operational supercomputer and live with it for quite a while as it falls further and further behind the cutting edge, and then make a big step forward and let it fall back again. That's certainly been the case with work that's been going on at NOAA in the last 5 years. Europe has also focused on methods that determine how you take data into a model. It's a method called data assimilation, or a step called data assimilation. It's in some respects more important than what data do you have. You get the data in properly and understand the errors that it contains. They've pioneered new methods over at the European Center for Data Assimilation. They are very computationally intensive. We have not been able to adopt those methods in NOAA's operating supercomputers because they are so intensive.
Do we need to?
Well, I was just going to transition and say we know it's a good advance, and so our scientists, again, OAR scientists, plus our satellite data scientists and our weather service scientists all together, developed a method that is as effective and less computationally intensive. And proof of that solidity of that advance is that the Europeans are now going to adopt our method because it does the same work more efficiently. So stay closer to the cutting edge in our operational supercomputers. It would be good. Places like our center down in Norman that I cited as an example emulate the kind of close coupling of research and operations that the European Center has. So we do know how to do that, and we do it. But we do it in a little more distributed and more topic-oriented fashion around aviation weather challenges, severe storm challenges, and tropical storm challenges than they've chosen to do in Europe. But we have a greater array and greater variety of weather phenomena in the United States than all of Europe combined. And so I think our plurality and our diversity suits this country's needs.
Thank you very much. Thanks, Mr. Chairman.
Yes, Ms. Edwards. We now, Dr. Brown, for your 5 minutes question.
Thank you, Mr. Chairman. Dr. Sullivan, the Chairman, the Vice Chairman, and I are all three pilots, and so we've been very engaged in weather issues for a long period of time and concerned about weather, and we're concerned not only from a pilot operational perspective, but also how it affects all of our constituents, and not only in our district, but all across this country. The fiscal year 14 request proposes $188 million for climate research and $82 million for weather research. If Congress were to spend $158 million on climate research and $112 million on weather research, would this help or hinder weather forecasting?
Additional funding in weather forecasting would certainly help that effort. My concern would simply be to understand what are we giving up. NOAA's climate research is not multi-decadal, century-scale climate research. It's climate research aimed at understanding and more closely relating phenomena such as the Pacific Decadal Oscillation or the Atlantic Meridional Oscillation to the weather phenomena that affect the United States, so that we can extend our lead times on forecasts out beyond 5 days to maybe 7 or 10 days. These broad underlying patterns that are at climate timescales, we believe are critical to unlocking those secrets.
Well, just to tag on to what Commander Bridenstine was just saying about the time interval between tornado forecasts, I just found it incredible that you would even question giving people more advanced time for a warning of an impending tornado. But let me go back to that same question. Let me ask it in a different way. Which contributes to weather forecasting more? $1 for climate research or $1 for weather research?
It depends on what each dollar is spent for, Dr. Brown. I can put $1 into some aspects of weather research that are going to make only a minimal advance, and I might make an advance in understanding just how El Nino affects 7-day storm tracks and sets up convective patterns in the central United States that would do a lot better for Oklahomans in understanding when they're prone to tornado outbreaks.
Well, I'm sure the people in Oklahoma would like to have had an hour warning on their tornado that was bearing down upon them. And I think $1 in weather forecasting research would have helped in that regard. Well, let me kind of change tracks a little bit. Dr. Sullivan, as you know, in 2012, a financial scandal was uncovered at the National Weather Service where a senior official moved money, certainly without authorization and very highly illegally they moved that. They moved it between different accounts. It was reported that the amount of unauthorized transfers of money may have exceeded $100 million over several years. Did these transfers in any way negatively impact programs focused on transitioning new technologies from research into operations?
Those transfers, Dr. Brown, were all within the National Weather Service itself, and they were typically transfers from systems accounts, software upgrade accounts, and things like that into operations and management. So they were, as the investigation indicated, well-intentioned on the part of the offending individuals, which doesn't justify the act, but well-intentioned to try to support the forecasters in their everyday work where they felt they had budget shortfalls.
$100 million is a lot of money. And moving things around illegally is certainly should not be done by anybody. And my concern is that when we talk about tornadoes, when we talk about what I face when I climb into a cockpit and what these other gentlemen said, weather is an important issue. I understand climate research, I understand weather research, and I just disagree with maybe my Democrat colleagues over where our priorities should be set, and obviously what you seem to be so wedded to as far as doing climate research. But the folks in Oklahoma need more advance warning, and I don't think it's government's responsibility to decide how they respond to that warning. We need to give people as much advance warning as they possibly can for a tornado or a hurricane or anything else. And doing weather research, I think, is extremely important. And I applaud the Vice Chair's bill that he's put together, and I think it's important for us to proceed, and hopefully it will be marked up and we'll pass it into law. Thank you so much, Mr. Chairman. Now you go back.
Thank you, Mr. Brown. Then our final questioner for this panel would be Mr. Weber from Texas.
Thank you, Mr. Chairman. Let me follow up, Dr. Sullivan, what Dr. Brown was asking about. I think when he asked you about the transfers that might have been illegal, you said the individuals were well-intentioned, I think?
In their own mind, Mr. Weber, they professed to be doing things that they felt kept the weather forecast enterprise healthy as it needed to be, in their mind. I don't defend the statement. I'm just reporting what they said in their depositions.
So were you aware of that when it took place?
I was not aware of it when it took place.
Mm-hmm. How soon thereafter did you possess the knowledge that it had happened?
I try to recall that timeline. It came to NOAA's attention through an Office of Investigator General complaint that was referred to us for action by the OIG. We very promptly acted on that, established in concert with the Office of the Secretary an investigation and inquiry panel, placed some individuals on administrative leave, and proceeded to conduct an inquiry.
And was that time frame a month, a week, a year?
The time frame from our receiving word of the problem to initiating the inquiry was hours. The inquiry was completed over several months.
Okay. Do you have knowledge as to what's happened to those particular individuals?
I do have knowledge, and as I know the panel appreciates under the privacy laws of this country, I can't speak to individual matters. Mm-hmm. In open session, we have shared those details with our appropriators.
Okay. Have they been, and I'm not asking for names or specifics, but have they been disciplined? Has anybody lost their job?
Individuals have been disciplined. Individuals are no longer with NOAA. Financial controls have been thoroughly reviewed across the entire department and modified and strengthened, and training has been put into place for all senior officials.
I find the term well-intentioned individuals kind of interesting because I'm just thinking when those, as you call them, well-intentioned individuals play fast and loose, if you will, with the rules, would you agree that one can certainly make that assessment? That they've played fast and loose with the rules?
That they were either woefully and inexcusably ignorant of the rules or played fast and loose.
Or they played fast and loose. We hear that a lot, in this capacity, that people are ignorant of certain things that go on. And I keep thinking to myself that they should probably run for Congress at that level of ignorance. Nonetheless, when we up here look at a situation where someone plays fast and loose with the rules, can you understand that it gives us pause for concern when somebody brings a budget request to us and says this is going to negatively impact our ability to predict climate change? And then we have to think, well, there's been reported incidences of people in that agency playing fast and loose with the rules. And I believe the quote is well-intentioned individuals who we would ascertain had played fast and loose with the rules. So when someone comes up with a budget request and they say this is going to impact us negatively, can you understand how we might draw a similar conclusion that maybe that's a fast and loose playing with the rules, that we might question that? Could you understand how we could come to that conclusion?
I follow your logic, Mr. Weber. I would ask that you attribute the well-intentioned to the people who said it, which are the people who were doing the actions.
Okay.
It's certainly not my characterization of them.
Okay. You don't want to be associated with it. I don't blame you.
I don't care to be associated with
Right.
it, and I feel, judging from your comment, my reaction to and response to that incident and those behaviors
Right.
very close to yours.
Right. Well, we would hope that there would be enough oversight and enough safeguards in that agency that kind of playing fast and loose with the rules, as it purports to moving money, some of us have been afraid it was actually illegally, would also purport to that when you come to this committee or when you come to Congress and say we need money for climate change, and yes, there's a disagreement about climate change, that there's not the same kind of fast and loose playing with the facts. And that's what's our concern. And I know that you can't speak for everybody, but we just simply ask you and implore you to make sure that kind of fast and loose playing goes away, and that, if you have anything to do with it, well-intentioned individuals or otherwise, you make sure we get the facts. And
I assure you that I will do that, Mr. Weber.
Okay, I appreciate that. Now I yield back.
Thank you, Mr. Weber. Dr. Sullivan, thank you for your time today. Thank you for your testimony. There's one item I'd like to follow up with, if I could, and that is, you may remember, last September you testified for the committee's oversight subcommittee on a hearing about the National Weather Service. And on November 6th, committee staff sent follow-up questions for the record to you as well as to one of your colleagues, Mrs. Maureen Wiley. The committee has not yet received response to those questions for the record. And I would ask if you would commit to me and to other members of this committee as well that you would answer those questions as soon as possible.
I certainly will make that commitment to you, Mr. Chairman. The formal clearance processes, as I know you understand, sometimes wreak havoc with the actual timeliness of delivery. It's my understanding that we've had staff-to-staff conversations on those matters, but the formal transmittal has been delayed.
Okay,
I commit we will work on that.
Can you give us some indication of when that process would be complete and we could expect answers to those questions?
I will probe where things stand and get back to you on that.
Okay. So you're going to get back to us on when you're going to get back to us. Is that okay?
I will get back to you on the timeline that I believe
okay.
I can commit to.
All right. Thank you for that. Again, one more time, thank you for your testimony today. And members of the committee, as we've discussed, can have additional questions for you, and we'll ask you to respond to those in writing in an appropriate and timely fashion. And the witness is now excused, and we will now move on to our next panel. Thank you, Dr. Sullivan.
Thank you, Mr. Chairman.
At this time, I'd like to introduce our second witness panel, and I'll introduce them individually and then allow them time for their opening statements. Our first witness today is Dr. Kelvin Drogemeyer, Vice President for Research and Regents Professor of Meteorology at the University of Oklahoma. Dr. Drogemeyer is a fellow at the American Meteorological Society and a member of the National Research Council Board on Research Data and Information. In 2004, Dr. Drogemeyer was appointed by President Bush to the National Science Board and was reappointed in 2010 by President Obama. He holds a PhD in atmospheric science from the University of Illinois. And I'll remind all of the witnesses that, as has already been stated, your spoken testimony is limited to 5 minutes each, and after which members of the committee will have 5 minutes to ask questions. I now recognize Dr. Drogemeyer for 5 minutes to present his testimony.
Good morning, Chairman Stewart. Thank you so much. Ranking Member Bonamici, Mr. Bridenstine, good to see you. Thank you so much for the privilege to speak to you this morning on a very important matter. I appreciate all the work that you are doing to help protect our citizens from the destructive forces of nature. I'll offer my perspectives as a professor of meteorology at the University of Oklahoma. I've been there almost 30 years working at the National Weather Center as a meteorologist, really at the nexus of severe weather in the nation, in fact, in the world. I witnessed firsthand last month as these tornadoes ravaged parts of our state, and many thousands of people no doubt would be dead today were it not for the extraordinary warning and prediction system we have in this country. So great thanks to NOAA and all the wonderful work they've done, but yet, in fact, our work is not done. We still have people dying. Even one death is really intolerable. I'd like to make three very brief points for you this morning. First, I really do welcome this bold, focused initiative on high-impact weather prediction. It builds upon a strong foundation that we have in this country, a very, very solid foundation. It prioritizes key topics, and really the only thing I would add would be to build on what Dr. Sullivan said in terms of the prescriptiveness of the bill, really allowing scientists to focus on the best tools and techniques to do things like assess observational needs. And I want to let you know that the academic community stands ready to work with you and to help you however we possibly can. You can marshal all of those resources. The second point was talked about in the last session. It's extremely important. As a meteorologist, it may seem heretical for me to talk about the social sciences, but in fact, this is a real people problem. Really, ultimately, what we're dealing with here is a loss of life. And our ability to deal with that means that we have to address the issues of how people understand and predict and prepare and so on, respond to warnings. We need to understand how we convey and formulate uncertainty and messaging to the public, how the public responds and comprehends warning information. There's issues of trust and source security of information and so on. And I think that we have to even ask ourselves whether or not the whole current warning and watch system really needs to be rethought from the ground up, starting with people, because the people are the ones who are affected ultimately. Also, I would like to talk to the issue of tornado warning lead time. As specified in the Act, this is a very, very important issue, extremely important, has to be looked at. But I think we want to be careful about not focusing entirely on that magical number, because ultimately the question is, as Dr. Sullivan mentioned, what are people going to do with that 1 hour? In my written testimony, I give you a little narrative of what I saw firsthand on May 31st in Oklahoma. Excuse me, as thousands of people fled their homes, put themselves in harm's way, because they had a very large amount of lead time without really knowing what to do with it. This issue resides in the domain of the human behavioral sciences. It's not a weather or technology problem. It's something we really have to learn how to address. And so I would argue that really our focus ought to be on the goal of zero deaths. Zero deaths. We achieved that in microbursts. Wind shear, you folks are pilots. You know, we had a lot of planes crashing back in the 70s. We had a concerted attack on understanding the causes of wind shear. We put in technology and training, and over 20 years now have passed since no one has died in an aircraft accident due to wind shear. Zero deaths is not an unattainable goal, and that puts our focus on people. Finally, I'd like to highlight the importance of a truly interdisciplinary approach. Dr. Sullivan and Ranking Member Bonamici talked about this a little bit in terms of our test beds. These operational test beds that we have that integrate research and operations are very important. They exist, but they need to be expanded and improved and enhanced. They do a really wonderful job, but we could yet do more. And I would suggest to you that this notion of research to operations is probably a little bit misconceived. It really says there's research over here and operations over here. I suggest that research plus operations, working hand in hand with the operational folks, working with the researchers hand in hand, as we do in Norman, this wonderful hazardous weather test bed that truly is credited with saving lives, developing new technology, and the rigors of operational activities with scientists and operations people working together. That, to me, is the way that it ought to be done. I would like to close by showing you a brief movie here of the May, the May 20th tornado and more. It gets to the question that was asked earlier about the value of MPAR, and this movie, I'll introduce it to you. We'll go ahead and start it. The first clip is of a TV station, KWTV Channel 9 in Oklahoma City. There's the Moore tornado. It's hailing. There's debris falling. And I'm going to freeze it on a radar picture from the TV station you'll see in a moment that shows where the current warning time comes from in part. It's where you have a given thunderstorm and then the path of the tornado is extrapolated based on its previous history. So there you see it. That hook-shaped image there in the lower left part is the tornado itself. That gray part's the debris ball, and the line moving from it to the northeast is the track of the tornado at various times throughout its history. And so that's where we got the 16, 30, 40 minutes of lead time. people in harm's way saw that image. What I'm showing you now is sort of the future. This is a picture of counties in Oklahoma, and the two lines of inverted triangles are actual tornado paths in 2011. We reran the forecast of this situation here. You see the radar echoes forming, and as you see, as this thing plays forward, you'll see these black contours, these dark circles, see them forming along the tornado track. This forecast was produced an hour in advance, experimentally, not in real time, but we got very, very close to predicting the occurrence of a real tornado, of a real event, an hour in advance. This is what is possible. Can we do it this good every time? No. You see some tornadoes down there in the lower right that have no real counterpart associated with them. So the science is not there yet. But 20 years ago, we didn't think this was even theoretically possible. Now we're not only able to show it's possible, but in the hazardous weather testbed, we're able to demonstrate it in real time working with operational forecasters. Thank you, Mr. Chairman.
Thank you, Mr. Domeier. I appreciate your testimony. Our second witness I'd like to introduce is Dr. William Gale, Chief Technology Officer of Global Weather Corporation and President-elect of the American Meteorological Society. He was previously a director in the Startup Business Group at Microsoft, Vice President of Mapping Products at Wetherell Corporation, and Director of Earth Science Programs at Ball Aerospace. He is a lifetime associate of the U.S. National Academy of Sciences Research Council, and Dr. Gale received his Ph.D. in electrical engineering from Stanford University. Dr. Gale.
Thank you. Chairman Stewart. Turn the microphone on, please. Thank you. Chairman Stewart, Ranking Member Bonamici, and distinguished members of the subcommittee. It's a privilege to be here today and provide testimony. Thank you for your invitation. As was mentioned, I'm co-founder and chief technology officer of Global Weather Corporation, a startup company providing precision weather forecasts to businesses within the energy, media, transportation, and consumer sectors. I'm also president-elect of the American Meteorological Society, and I was a member of the recent National Research Council study advising on future directions for the National Weather Service. This is a tremendous time to be part of the weather community. We have an opportunity to serve the nation, our citizens and businesses, far more effectively than has ever been possible. The reason is simple. Our work involves three basic activities: observing the current weather, converting that information into forecasts, and getting the results to the people who need it. Each step in this process has been sequentially revolutionized, beginning in the 1960s with the advent of satellites and ultimately Doppler radars, continuing through the 1980s with rapid improvements in computing and weather forecast models, and finally today with broad adoption of the internet and mobile phones. We're now beginning to deliver the ultimate vision, individualized weather information matched to every user's need, time, and place. So why is this important? Well, Sandy and the Oklahoma tornadoes reminded us that we can and must do far more to protect lives and property. But often forgotten is the great potential of weather information to drive economic growth. On average, economic output at the state level varies by up to 3% from one year to the next due to weather variability. In 4 of the 8 states represented on this subcommittee, the variation is over 8%. Improved weather information can clearly be a growth engine for the nation's economy. Indeed, in every market my company enters, we find opportunity for efficiency improvement. For example, Xcel Energy uses 10% of America's wind farm capacity. An improved wind forecast system saved $22 million for the ratepayers in 2012 alone. The trucking industry lost $18 billion in 2011 to weather-related accidents and delays, yet weather forecasts are not routinely used. A company called Telligis is about to change that, providing weather and road surface forecasts for every mile of major road in the country. All this is made possible by the American Weather Enterprise, a truly remarkable collaboration between academia, government agencies such as NOAA, and the private sector. Working cooperatively allows us to be bigger than the sum of our 3 parts, a key reason for our success. One current goal is to unify our voice and provide prioritized, community-based guidance for legislation such as this. To this end, a group of enterprise leaders recently met and agreed to build an advocacy organization called the Weather Coalition. It's important to recognize that our strength arises from breadth. Space weather, hydrology, oceanography, and coastal meteorology are key sister disciplines to weather. Both near-term and long-term weather are important. One often hears that businesses need a predictable regulatory environment to plan long-term growth. Predictable climate is needed for the same reasons. Whether it is a military strategist analyzing regional vulnerabilities over the coming decade, or simply a parent planning a sunny day for their daughter's wedding next year, understanding climate and its variability are integral to weather forecasting. Rather than dividing the weather and climate communities, we need to bring them together to improve forecasts at ever longer timescales. Now, we do have problems to address as a community, from the looming satellite gap to forecast model performance. The Sandy Supplemental already helped substantially, but our problems are not simple. The issues are interlinked, requiring collaboration across NOAA and often the entire enterprise. The proposed legislation, while admirable for furthering forecast improvement, is too limited in scope, too prescriptive, and not sufficiently guided by broad community input to accomplish what the nation deserves. I urge you to build from this legislation, drawing on community advice and encouraging innovative solutions within NOAA and across the enterprise. Unlike most people who have the honor to serve as the AMS president, my career has not been entirely within the field of weather. That gives me a bit of an outsider perspective. My experience is that the people in this field, and I enthusiastically include those in NOAA, are the most dedicated, passionate, and innovative people I have ever met. To a person, they have one focus: make the nation safer and more productive. Give these people your legislative support, and they will return the investment many times over. Thank you.
Thank you, Dr. Gale. Today's final witness is Dr. Shuyi Chen, Professor of Meteorology and Physical Oceanography at the Rosenthal School of Marine and Atmospheric Science at the University of Miami. She previously served as an editor for Weather and Forecasting Journal at the American Meteorological Society. She is a member of the National Academy's Board on Atmospheric Science and Climate and a fellow at the American Meteorological Society. She received her PhD in meteorology from Pennsylvania State University. Dr. Chen.
Chairman Stewart, Ranking Member Bonamici, and other respected members of the subcommittee. Thank you for the opportunity to testify before you. Important issue, including weather forecast. So I'd like to focus on my testimony on 3 points regarding the bill, and many have been stated. I wouldn't repeat. These are my personal opinions, although they are very much based on the number of studies conducted by the National Research Council of National Academies. The first point will be probably the most important point. I'll come back to that. So I would like to make a comment on the second and the third. The second is refer to a point in the bill about specific technology evaluating observing system in terms of using numerical models. I would say in its present form, it's a bit narrow and prescriptive. So we would like to see that to be broadened to address the challenge that we're facing in terms of having that technology more flexible and including other new technologies that is currently in place. In terms of weather prediction, we have made tremendous progress. The point I'd like to bring your attention to is that we're at a crossroads that we face new challenge. One of the issue is that we can actually making the weather forecast beyond 2 weeks. This is where I think the weather and climate will come together, because this is an important area. In fact, in Florida, when we're making forecasts for hurricanes, the long-term projection into the next several weeks, called a subsequent forecast, is important, because that's the time we need to make plan for instance, water management. These science that can be done nowadays much better than we can imagine before. So again, follow the same theme. I think weather and climate are connected. They both needed by the society. So I think we're ready to do that, and we certainly like to see that happen. So now I'm going to the first point of my testimony in terms of a need for a holistic approach to the transition from research to operations. As you all know that we have made a tremendous progress in terms of a high impact weather, like the event in Moore, Oklahoma, and Superstorm Sandy. The problem that we're facing, the challenge that need to be resolved, is the following. The research and the operations sitting on two boxes, they're not well connected. They're all well intentioned, as we probably heard before, but there is no connection between them or no link. So we have not made much progress, even though a lot of studies have suggested we should. So I think Congress can help us in terms of providing that linking piece. This is where I think a national advisory board would help to make that decision, transition from the research that not only at OER NOAA, but also broader research community that is driven by users' needs. And at the same time, we would like that the body of oversight this important effort to making decisions, transition to the National Weather Service. Currently, many models, not only they're not running in real time by NOAA operations, they have no pathway to even getting into NOAA operations. So this is where I think Congress can help to bridge that gap. So last thing is I would like to show you a research that is done, many research has been done for Superstorm Sandy. And this is a familiar picture, and I'd like to see you to be the judge to see what research has come along and whether they should be going into operations. This storm taught us a lot of things. Many things has worked well. One thing we recognize as Sandy, as a hurricane, does not live in an individual world, interacting with its environment. And many models had made forecasts quite much in advance. If you look at the panel on the right, that many global model projected track and way in advance, especially one of the model from Europe that projected 9 days before the storm have a high probability hitting the northeast. On the other hand, our high resolution model to your left can really get into the nitty-gritty details and into the storm to looking at a much detailed impact in terms of rainfall and so on, the interaction between the storms. And furthermore, the models conducted at the university level, we have made much more progress in terms of resolving the surface winds. For instance, the red panel is model prediction and the left panel is observed from satellite. Those are, you can't really almost tell them apart. The research are really progress. In terms of forecasting impact, these are you're looking at the surface wave and the ocean sea level height. This was not imaginable many years before, but recently we can really quantitatively looking at the sea level heights when the storm approaching, especially to the right where you have water pushing onshore, and to the south, it's a water point south, further south. So we can quantify this information much more by going down to some other high-resolution storm surge impact forecast. All this is available now in the research community. The last thing you will see a movie that is model simulation of this two weather system that interacting. One is a Sandy as it's approaching the land, and the upper atmosphere have this wave that we call the mid-latitude system that interact with the Sandy. They wrap around each other, dancing around, and this has made Sandy extremely special. So this type of research is solely available, and unfortunately, many of these models developed in the research community have no pathway to go into operation in NOAA. We would really like to Congress to address this important issue moving us forward. Thank you.
We thank the witnesses for your testimony today, and we remind members of the committee that rules limit the questions now to 5 minutes. And the chair at this point will open the round of questions, and the chair recognizes himself for 5 minutes for questioning. I'd like to expand a little bit on some things that have been said both in this panel and in a previous panel. And Dr. Drogemeyer, I'd like to begin with you and your desire, I think the goal, where we said we had an objective of trying to have 0 deaths from hazardous weather. And you said that that was an achievable goal. I'd like to open that to the other members of the panel. Do the rest of you believe that that's an achievable goal as well? Dr. Gale?
My specific knowledge on this issue is somewhat limited, so I prefer not to say what an achievable goal is. But certainly we have continued to make progress in our ability to forecast. And so improving beyond what we're currently doing towards an hour, to an hour, past an hour, is definitely a worthy goal, absolutely.
Okay. And Dr. Chen?
I think in terms of scientific knowledge, the predictability, which means how long or how far in advance we can predict a certain phenomena, it's very much still in the research that we're trying to search for these answers, because atmosphere ocean as a system that has a limited predictability. In terms of scientific findings, we're not at stage we can tell exactly which phenomena, how far once we can, but we'll certainly search for the answer, including hurricanes. Is a hurricane predictable 7 days out or 30 days out? That's an open question.
Okay. And look, I understand you can't account for people doing foolish things. You can give people adequate warning, and they can ignore it. They can run into the face of the storm. People will do dumb things sometimes. But the point is, you give them the information that would allow them to protect their property and their own lives in many cases. And Dr. Drogemeyer, I'm wondering, do you want to expand on that, or will you just leave it at that? That this is an achievable goal, because I believe that it is an achievable goal, with the exception again of sometimes foolishness.
Yes, sir, Mr. Chairman, I agree, and I think part of the point of that is to get our focus on what is really important. There are lots of metrics that we can use to measure forecast accuracy, reliability, lead time. All of those things are floating around. At the end of the day, though, it's about people dying. And I think if we say, what is it going to take to get us to that place of 0 deaths, then it really forces us to confront the difficult challenges of understanding what those deep problems are. But you're quite right. I think there are going to be circumstances where people will die unnecessarily due to decisions they made, but I think we can do a lot better job of conveying information, formulating it, and helping them understand what the consequences of their actions are.
This is the money that we spend on weather research and weather studies is money well spent. We have an achievable goal here that would be dramatic and some would say fanciful, but it's not. And I think we would obviously support any efforts in order to move towards that goal. In my remaining time, I'd like to come back. We had an interesting exchange between Mr. Bridenstine and the previous witness, Dr. Sullivan, where there was this a bit of an idea about, can we give 16 minutes or could we give an hour? And I'd like to explore that just a little bit, and that is, again, the idea that, just very quickly from the three of you, if we could give someone an hour's warning, that's always better than giving them 15 minutes warning. Does anyone disagree with that? Okay, no, of course not. I mean, clearly it's better to give them an hour than 15 minutes. But then, if any of you would like to talk about some of the concerns we have with giving people more time, I mean, what's some of the reactions that people have that make it so they don't take advantage of that, or how you have to communicate that? Any on the panel like to address that? Dr. Gale?
Sure. One of the big challenges we face, not only in this area, but in all aspects of weather, is how to get the right information to the right people at the right time. So you can have an hour warning, but to get it to them in a way that they can act on it and they can choose to do the most appropriate thing for themselves is still a big challenge. And so when we say we want an hour warning, the next step is to make sure that that information does in fact get to people. It doesn't just come out on some single website. That is a challenge, being able to get it to them in a way that they can make best use of it.
Okay, thank you. Then it seems like we have two problems. One is the technology and the research in actually providing the whatever it's 45 minutes or an hour, as long as it might be, and then kind of the human element of helping people to take advantage of that. But we don't want to make perfect the enemy of the good. Recognizing that there's challenges on the backside doesn't diminish the great good that can come from expanding and lengthening the amount of time we could warn people. Okay, and my time has expired again. Thank you to the witnesses, and I now recognize the ranking member, Ms. Bonamici.
Thank you very much, Mr. Chairman, and thank you to this very distinguished and knowledgeable panel of witnesses. In some of the testimony, it mentioned 3 reports, recent reports that have studied how we can improve weather forecasting. One from the National Academy of Science, one from the National Academy of Public Administration, and then NOAA's own Scientific Advisory Board. And in those reports, they did discuss the issue that you brought up, Dr. Chen, about the moving innovation and research from labs to the weather forecasting operations. My impression is that there has been a lack of communication and an inability for those entities to connect, and that's something that hopefully we can address through this legislation. But I wonder, could you talk also about other recommendations in those reports? Are there recommendations in those reports that could help improve the legislation? Because we all have the same goal here of improving weather forecasting. Can we make use of those reports in other ways? Do you want to start with Dr. Chen and then the others?
Thank you. I'd like to follow up on that. There has been many studies from the National Research Council, and each report recommend almost exactly the same thing. We need a systematic approach to research, from research to operations, and to transfer the innovative technology. Our current system so far has not worked as well. Like I mentioned, the research and the operations are somewhat separate. So I think this particular panel and this particular bill could help us to address that in terms of providing that mandate, perhaps a national advisory board. Even though the funding has been appropriate to do this work, right now the problem is the structure that are not allowing the smooth transition from the research arm of NOAA to the operations, and more importantly, from the research community from outside, a lot of from academia and private sectors, we have not been able to making that transition to NOAA because the system are not allowing that flexibility. I think that.
Thank you, Dr. Chen. And Dr. Gale or Dr. Drogemeyer, do you agree with that? Do you want to add to that? But the information in the reports that may help inform the legislation.
Yes, these are all excellent reports and provide a substantial basis of community input upon which legislation could be based. Helping NOAA move forward with implementation of these recommendations within legislation, I think, would be a very valuable thing.
Thank you, Dr. Drogemeyer.
Thank you very much. I think we do have some exemplars of these kinds of test beds that truly are integrative, where you bring in the operational folks, they're already there, you bring in the academics, you bring in other researchers, and they all work together toward the common goal. And not being parochial, but the one we have in Oklahoma truly is unique, because we have the university co-located, as Dr. Sullivan said, with an OAR lab, with national operational centers, plus a forecast office. When those folks get together, wonderful magic things happen. And that sounds a little trite, but it's really true. And I think we can replicate that model.
Right. Thank you. Dr. Sullivan agreed with you in her
yes,
testimony.
Ma'am.
So,
thank you.
And there's a requirement in the draft legislation about the OSSIs. And can you explain briefly other kind of evaluative tools that might be used? There's a requirement that may be too constraining, we heard in the testimony. So if anyone wants to address, are there other kinds of evaluative tools that might be used instead of OSSIs? And is that flexibility important?
I can address that real quickly. There are a variety of techniques and tools, one of which Dr. Sullivan mentioned is the adjoint technique. Basically, it tells you where the forecast error will be large and where you need observations. What's important about that is you can, if you're not careful, put observations where, in fact, they're going to degrade the forecast, because it will put errors where you don't want errors to be and grow. And sometimes these other assimilation techniques will actually create observations where they don't exist, and you actually don't need observation. So it's a very, very complex problem. We need to understand it. And I think the only thing that we're saying is basically there's many tools available. Probably let the scientists decide which ones are most appropriate. We're not at all discounting the value of OSCEs. We're just saying there are other techniques used in concert would be helpful.
Thank you. That we heard testimony about that flexibility. And in my remaining time, I just want to follow up on the social science research that Dr. Drogemeyer, you talked about and the chairman mentioned about the importance of how to communicate. Of course, the timing is important, but the message is important as well. So it was an issue in Katrina as well, how that communication is and how we get people's attention. So maybe if any of you want to, in my remaining time, just add how that research can be furthered through this draft bill, please.
In the remaining 2 seconds.
Sorry, I'm out of time. Well, I yield back, and maybe I'll ask for some input in writing from the witnesses about that important issue. Thank you, Mr. Chairman.
Thank you, Ms. Bonamici. To the Vice Chair, Mr. Bridenstine.
Thank you, Mr. Chairman. Mr. Drogemeyer, I had a question for you specifically about the multifunction phased array radar. Earlier, you showed a video, and you had those two lines, and you were suggesting that we were able to predict tornadoes an hour ahead of time. Is that accurate?
Correct, and that was with a numerical forecast model, if I failed to mention that. It was initialized with radar data, but you were seeing simulated with a model radar data there.
Okay. So as far as our numerical model, how do we compare to the rest of the world in our ability to use that?
With these particular models, we call them cloud resolving models, we lead the world. There's no question. In fact, we pioneered this whole area of the fine scale prediction. Other groups are now doing a lot of wonderful work, but we really lead the way on that.
And on this multifunction phased array radar, is there anywhere else in the world that has that?
In military circles, a phased array is used a lot, as you know. As far as phased array weather radars, really, I think we are leading the area there as well.
Are there multiple of those in the United States, or is there only one?
Right now, there's one test bed in Norman called the National Weather Radar Test Bed. A lot of development going on. The FAA and NOAA are jointly looking at a system that would not only track weather, but also track aircraft as well.
Wonderful. So if you were to have, is there any talk of maybe one day eventually networking multiple multifunction phased arrays radars together, networking maybe throughout the greater Oklahoma City area to provide as much energy as possible into a specific target for purposes of, no kidding, enhancing that 1 hour capability that you've already identified?
That's an excellent question. In fact, the National Science Foundation almost 10 years ago funded a center to focus just on that, where instead of having large phased array radars, you actually have smaller ones, and they talk to one another, and they collaborate and say, hey, there's a tornado over here. Let's focus our attention on that, because that's what's really important right now, and then later on focus attention on something else. So that has been done experimentally, and we're looking at that as part of the operational system going forward.
The distributed networking capability that we have leveraged inside the United States military, it seems, would be highly valuable to get better information for weather. But certainly, one other thing, when you think about the multifunction phased array radar, is this a technology that would be kept in the public sphere, or is this something that the private sector could eventually advance and develop apart? Is there any revenue model by which this could be valuable for a private enterprise?
That's an interesting question. The private sector is actually involved in helping develop the prototypes. Various companies are doing that. As far as the operational structure, that's a good question. Would it be a government-run system, or could it be a privatized system by which the government would purchase data? Or I think that needs to be looked at. That hasn't been decided yet.
Okay. I yield back. Thank you, Mr. Chairman.
Thank you, Mr. Bridenstine. We now turn to Ms. Edwards, gentlewoman from Maryland.
Thank you, Mr. Chairman, and thank you to our witnesses. I want to focus on behavioral and social sciences research, because in the time that I've been on this committee, we have held hearings, not recently, on the use and effectiveness of social science research, and there are a number of members of this committee who have point-blank rejected the use of that kind of research in the work that we do. And so I'm intrigued, Dr. Drogemeyer, by your testimony, and in particular on page 5 of your testimony, where you point both to a University of Oklahoma preliminary study as well as to the events surrounding the May 31st hurricane tornado rather in Oklahoma City and Norman and surrounding communities. And you make a really compelling argument for the integration, building on a foundation of social science and behavioral research that would augment the kind of weather forecasting that we also need to invest in. And so I wonder if you could be a little bit more specific. You have one recommendation for building on that, but where, in what agencies would it be most appropriate if the federal government were involved in funding some of that research? I know that we do fund some research in other agencies, NIH, National Science Foundation, and the rest, but it's not all focused on weather forecasting. So if you could share your thoughts about that.
Thank you very much, Congresswoman. That's a really important point. And I think the term social sciences research is misunderstood. I think a lot of folks don't really know what all that involves. But the questions that we need to address are really fairly clear. They do involve human behavioral work. You're right. The National Science Foundation, National Institutes of Health, a lot of studies have been done, people that look at trust in terms of information and communication and verification. There's a broad body of literature already out there, but a lot of the social scientists, in fact, most of them, I don't think realize the opportunity that is available for them to come and link up with the weather community to really understand how to apply this body of scholarship. Number one, that already exists. Number two, to do new studies that are geared specifically toward the weather challenges. But I think a lot of it is misunderstanding of what the social sciences are really about. And I have to say, I had that same misunderstanding until I began working with them and really seeing the virtue of their activities.
And I did until I came to serve on this committee. I didn't get it at all. I thought it was kind of silly making, but it turns out that understanding behavior really should connect with the kinds of technology advances that we see. Do you have an idea of how much is spent, or whether it would be worth it to have some of those resources actually engaged through the National Weather Service and NOAA?
I think that's a good question. I don't know the amount of money that is spent, across agencies or even within agencies, but I do think that NOAA, it doesn't need to stand up a whole big social sciences activity. I mean, universities have entire social sciences programs across many, many departments, so I think NOAA is in a position to leverage that. But I do think there has to be a presence within NOAA that recognizes and helps, as Dr. Chen mentioned, transfer those research outcomes into the operational mainstream of decision making and behavior in terms of how we do the warning and watch system.
Great. And just with my remaining minute and a half, I want to each of you, if you could, to comment on the link, a link that you see or don't see between balancing NOAA's work on climate with the work on weather forecasting, and whether or how those things are connected, and whether you think that we've struck the right kind of balance.
Let's imagine that we didn't have a debate on anthropogenic climate change, human climate change. I believe we would be doing the same research on climate that we're currently doing just to improve our weather forecasting. So what we're doing is really essential to what we're doing in climate.
Yeah, I want to comment on the jointness of weather and climate, because the system is together. There is no artificial dividing line. For instance, hurricanes, we are very much in need of information of few weeks outlooks, so exactly for the water management. And at the same time, as each storm close to landfall, we do transition to the forecast part very smoothly. So I just want to also possible follow up on a question of the usual using social science to address this issue. Hurricane, for instance, is 7 days ahead, whether we can give warnings and whether it's good, because that is interesting social science question. A lot of times our forecast is not precise, and that could be over-warning can actually do harm in terms of people's actions. So those are connected issues that need to be addressed.
Thank you, Mr. Chairman.
Thank you, Ms. Edwards. And we appreciate your comments regarding the social science. And some of you may be interested to know that Section 5 of this proposed legislation has extensive foundation there for encouraging the social science and some of the communication process as well. Our final questioner then today is the gentleman from California, Mr. Rohrbacher.
Thank you very much. Let me just note that there has been a great deal over the last 15 years of money spent specifically to prove that humankind is causing the climate change, to suggest that would at the same time benefit weather forecasting stretches credibility, because people were given grants specifically to prove that, and other people were denied grants unless they were willing to prove that. Let me go back to a question that seems to have been asked before, something about this climate research, going back to challenge the point you just made. For the dollars that we are spending in climate research, would not those dollars be better spent on weather research that we know affects and puts people in danger right now?
Yes, thank you for the clarification, and I was really specifically referring to NOAA, where really the large part of the climate research is focused on improving weather forecasting, and so
Department of Energy, et cetera, has spent enormous sums of money on trying to prove that human beings are changing the climate. That has not helped weather forecasting. Let me get into this one last thing, because I've got 3 minutes to ask questions as well. Let's get the answers from you folks. I understand that there is a gap. Let's go right to weather forecasting. That there's a gap that will be appearing, if it's not already there, in the data provided by polar orbiting and geostationary satellites. There'll be a gap in that information. Is that correct? Is that predicted? Is it happening now? Is that something that's predicted? Whoever.
That is certainly anticipated. I do come from the satellite industry a while back, and you can never know how long a satellite is going to last. But there are certainly risks and widely recognized risks.
So this is there's a significant gap that we are facing in the information that we have been getting from these satellites. Now there was a hearing last year in which Dr. David Crane stated that possibly commercial satellite data, getting that data commercially might actually be the most cost-effective way of doing this. But yet, in this observing systems simulating experiments, that NOAA hasn't really looked at that option. Should NOAA be looking at that? Should the OC system focus on whether or not we can cost-effectively utilize private satellites to fill this gap that's expected? Anybody?
I'd just say the OCs themselves are really agnostic in terms of who operates and builds the satellites. It really is telling what sensors are needed and how rapidly and so on. So it really doesn't. The OC itself doesn't address the question you're asking.
Right, but should NOAA then be taking the steps to see if this would be a cost-effective way of meeting this need that we will have in the future in terms of the data gap? For some reason we shouldn't use private satellites?
Oh, absolutely not. I think there is a lot of room for innovation here in terms of how we access data, whether it comes from the private sector, whether it comes from the government, and it should be done in the most effective way possible. Absolutely.
Right. Let me just note, Mr. Chairman, that there are some things the government has to do, and there are other things that can be contracted out. And before SpaceX arrived on the scene, everybody thought government had to provide all the transportation systems to and from space station, for example. We've already saved about $500 million using SpaceX, perhaps using commercial satellites, which have other functions that they can sell in the private sector, might be a good way to get in the information that would protect us from this data gap that we're going to face in the future. Thank you very much, Mr. Chairman.
Thank you, Mr. Rohrabacher, and I share your concern as well that satellite coverage gap between 2015 and 2017 is troubling for us, and we hope this legislation is able to address some of that. Let us conclude then. We thank the witnesses for your valuable testimony and for the members for their questions as well. And once again, the members may have additional questions for you, and we will ask that you respond to those in writing The record will remain open for 2 weeks for additional comments and written questions from the members. The witnesses are then excused, and this hearing is adjourned.